Hey, welcome to this organic chemistry video. This is for Danish. There's a question about compound T, which is that, and there's its mass spectrum. And the first thing we have to do is find out the number of carbon atoms. So as you all know, the number of carbon atoms is equal to the n plus 1 peak divided by the n peak times 100 divided by 1.1. And this is the n plus 1 peak, 3.4, divided by 33.9, times 100, divided by 1.1. I've done it already. It's 9.11, which is about 9 carbons. Okay, so we've done the first bit. Not too bad. All right, so X, number of carbons, is 9. Okay, 9 carbons. We're told it's CXHYOZ, so now we know it's C9HYOZ. We've got to find the molecular formula now. Right, so going back up, if you look at this diagram here, this one is the M peak, and this little one is the N plus 1 peak, caused by the carbon 13s. All right, there you go. So there you go. So the molecule therefore has a mass of 150. So C9HYOZ has a mass of 150. 9 carbons have a mass of 108. So we have 42 to figure out. All right, so at the moment it's C9HO. Let me put 1 oxygen in. That's 6, 26. So if I put 1 oxygen in, there's 26 hydrogens. That's too many, way too many. So let me take another 16 away. I get 10. This becomes H10O2. That looks reasonable. So I'm going to say C9H10O2. All right, because this makes 150. All right, and that's a reasonable ratio. All right, interestingly, the ratio between the carbon here and the hydrogen is about 1:1, which suggests there's an aryl group. In other words, there's a benzene ring. Okay, if it's about double, if you get something like C9H20, it would suggest an alkyl. But if it's C9H10, that suggests an aryl. So there's a benzene ring in this thing. All right. Identify the fragment lost at 119. Sorry, there's a peak at 119. What is lost? Okay, so my full thing, C9H10O2, is 150. All right, now, and I get to 119. So 119, if I take 119 from this, I get 31. So I've got to get something at 31. Something that's lost that has a mass of 31. All right, so carbon, I'm going to start with CHO. Now, it's a very common CHO, you should all know, has a mass of 29. All right, that's 12 plus 1, which is 13, plus 16, which is 19, 29. Okay, so this is too small. All right, so I've obviously got to increase this, and I do that by saying CH3O, and CH3O has a mass of 31. So it doesn't want what the peak is, it wants the peak, what was lost. So what was lost is this, CH3O. All right. Interestingly, it is not charged because this thing is not what made the peak. What was lost, this peak here is charged, but this is uncharged. Okay, because if this was charged, we would see a peak at 31, and we don't. Okay, so CH3O. Now, so that's that bit done. Let's move up. Next bit is a bit on infrareds. There's an infrared spectrum. You've got to identify the peaks at V and W. Now, this one is about 1700. This one is about 1250. Look it up. These are the ones that you should know, all of you, without even looking anything up. But 1700 is a CO group, and 1250 is a single bond, C single bond O. So this one is a C double bond O. This one is a single bond O. All right, and it wants the bond responsible. So you can't say something like this. You can't say that All right, because that has that bond, and that bond. You've got to be very specific. This bond is cause is the 1700 peak, and this bond is about 1250. All right, 1 mark, piece of cake. Okay, let's move up. I think this is the bit that was causing the problems. Maybe I'm wrong, I don't know. The NMR spectrum in CdCl3 is shown. 3 hydrogens, 3 hydrogens unsplit, 4 hydrogens in a weird pattern there. Okay, so when they do this, they mean there's a benzene ring. There's a benzene ring, hydrogens. All right, so there's 4 of them. There's my benzene ring, and since there's 4, there must be 4 hydrogens. 1, 2, 3, 4. Therefore, there's something on one side, something on the other side. Okay. Now, 4 hydrogen means the benzene ring must be disubstituted. In other words, there's 2 things on my benzene ring. If there was a peak of 5 hydrogens, if this had an integration of 5 hydrogens, it would mean it's monosubstituted. In other words, there's 1 thing on my benzene. Okay, like that. There's 1 thing on it, but this thing tends to suggest there's 2 things on it. Okay, I don't know where they are. They could be at positions 1, 2, 3, 4, 5, 6. They could be positions 1 and 4. I don't know. All I know is this disubstituted. Disubstituted. All right, so that's where I'm going to start. Now, don't forget what we've got to play with. We've got C9H10O2. Okay, now these are isolated from everything, and so are these. So we've got C6 so far, C6H4. So what have we got to play with? C3. Sorry, yeah, that's right. C3H6O2. All right, so let's start playing. This is how I would do it. Let's put an oxygen there and a CH3 there. That would give one of these. I don't know which one. I'm not looking at the data booklet. All right, that gets rid of one of them, and maybe another one down there. Would that work? Well, I'll tell you why it wouldn't work. All right, but let's have a look at this in a minute, because these are different peaks. If this and this group were the same, that you'd get different. Sorry, if these groups were the same, you get the same delta value. I've just seen that we're short 1 carbon, so it can't be this. All right, so let me stick another carbon in somewhere. What am I going to do? I'm going to go OCH3 for 1 group. All right, because all the protons must be the same. And now I'm going to stick it there. I'm going to go for that. All right, now does this work? Let's have a look. These four, let me pick a different color. 1, 2, 3, 4. So that looks good. 3 isolated there, all the same, yeah. 3 isolated here, all the same, yeah. If you want to know the values, you should look at the booklet here, the data booklet. Okay, I'm not using one, I'm just guessing a bit here. All right, so the type of protons at 3.9, it's either CH3 protons connected to an oxygen or the CH3 protons connected to that. It's one of those 2. I don't know which one, but you can find that from the book. Okay, these ones are the aryl protons, these ones here, connected to the benzene ring. So I'm going to guess as this as my answer. It fits everything. Let's check it's C9H10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's C9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Oops, H10 and 2 O's. Yeah, that looks good to me. I'm going with that. I hope it's right. We'll see. All right. So let's move up and let's do the next bit. So this one's quite a long question, isn't it? So which one have I got now? Is it that one? Yeah, I think it's this one. Peaks at The BCAT 2.4 is due to a proton attached to a saturated carbon atom. Okay. State 2 possible types of proton. Oh, this is interesting. So let's have a go at my picture again. I think I've got it wrong. Okay. Oops. I'm getting confused here. There's my picture. The BCAT 2.4 is from a proton attached to a saturated carbon atom. Okay, so, well, it could be this one, couldn't it? Yeah, these are next to connected to a saturated one, and so are these. Okay, so state 2 types of possible proton. Well, it could be a CH3 connected to a carbonyl, or it could be the CH3 connected to the benzene ring. Okay, they're the 2 types, aren't they? It could be. Adding D2O to T does not change the position of the NMR, does not change its proton NMR. What does this tell you? There is no labile protons. Okay, no labile protons. Labile protons. Okay, no proton transfer. All right, let's do the next bit. Okay, that one. Oops. Oh, there you go. There's some there's some isomers here. What was the other one? Sorry, let me see. I was going to add another one. Oh, it's a table. Okay. All right. What are the 2 functional isomers? Or 2 possible isomers? All right. Now, I don't think I've looked at this enough, have I? CH3, and we could have an O there. We could have a C. That's not right though, is it? Okay, so we're going to get rid of that. And go back to this. So there's got to be an O here, or a C here, there. That's one possible. Or could we have this? We could have an O, C, O, CH3, and then we'd need a CH3 here. Okay, I think they're the 2 we can get. Anyway, if there's anything wrong, any questions, just ask. Okay. All right. Thank you.